Hi, my name is Alex Graveley. As I was just saying, I'm not going to talk about what I was written down on the schedule to talk about, which is my projects Gimme and Pyro. But if we get through this quickly, I can give a demo of them if you guys want. I'm here to talk about streaming virtual machines, which I think is a really cool idea, and it's something I've been working on at VMware for the last few months. And so I've got half an hour, so I'm going to go through this pretty quick. So VMs are pretty cool. How many people here know what VMware does, know what virtual machines are? Awesome. So I'm going to skip explaining to you that they're kind of a sandbox environment that allow you to do a lot of really cool stuff, like treat a physical machine as a bunch of files. So a big problem with virtual machines today is that they're really, really big. I mean, you're talking about entire systems in a set of files. Vista is, upwards of 10 gigs. A fully loaded Ubuntu is, some number of gigs as well. And in order to sort of be able to play with VMs and do cool things with them, you really need a better way of getting access to them. And so it's for a variety of reasons that it's difficult to access today. They're most people take them and then compress them and put them in a zip file and then upload them to a web server where someone else will then go and download them and then uncompress them and then run the virtual machine. And that's pretty inefficient, and it's kind of annoying because you end up downloading a few gigs of compressed data and then you have to do all this prep. And so it would be really nice if this was a little more streamlined and if it was easier to sort of share what you've done inside a virtual machine with other people. So what we've been working on is something called VM streaming, which is a new feature in Workstation 6.5, the beta that just came out a little while ago. And the idea is here that you download VM bits directly as you're running them from a web server using standard HTTP range requests. The idea is that when a virtual machine which is running on your local computer asks for certain disk blocks that are currently not available, we'll go to a web server, ask the web server for those disk blocks, return them, save them in a download cache, and then hand them back to the virtual machine. And this works with any VM stored on any web server, and all your changes are running locally on the local machine, and any changes you make are stored locally, so we're not stealing your data. I guess I'm going to kick off this process to sort of let you know how it works. So I'm going to go to a web browser here. This is my sort of personal web browser. There's a couple of VMs uploaded here. I'll just go here and I'll click on this link right here, which is going to open a special virtual machine URL, which is handled by Workstation or VMware Player. And so we'll say launch that. And in a little while, we should get a booting virtual machine that doesn't exist on my computer yet, but will in a few minutes as we download what's required in order to make it run. And so this is pretty cool because I didn't have to think at all about where I was going to put that VM. I don't have to think at all about downloading or uncompressing it. I don't have to wait to download the entire thing just to run it. And so what's actually happening behind the scenes here is that we're going to my personal web server and downloading the blocks that are required in order to feed this VM. So that's kind of cool. We'll let that boot. I guess we can start up some other ones. There's let's see, there's this other one here, and we'll start that up also. And then we can go back to them as they boot. So it really depends on sort of the size of the VM. It depends on whether or not you've compressed this virtual machine on the server side. These kind of things affect how fat your pipe is. These all sort of affect how fast it'll download and how fast it'll boot. But in pretty much every case, it's going to boot faster than if you were downloading a few gigs first. So there's two virtual machines that didn't used to exist on my computer and which are now running locally and in the process of booting. I guess I'll go back to these slides. It's already in there. If you download the beta, it's already there. Yeah. Okay, so what's this good for? It's nice because it allows you to try out new stuff without any sort of prep time, without thinking about it, without having to download it. It also allows you to run really big VMs that are stored on a remote storage without having to copy them locally. Because basically you're only downloading the bits that are asked for by the virtual machine. And it's cool for things like testing nightly builds where you don't want to download an entire VM just to test to make sure something runs, delete it, do it again tomorrow. You can just click on a link in a web browser and it'll figure it out. Another cool thing is just sort of why I'm really excited about it is the idea of making it really easy to publish virtual machines. Because now what you can do is just take a virtual machine directory and upload it to a web server, any web server, and any virtual machine, in fact. And just point your friends at that URL, and they'll be able to run that virtual machine on their computers, just as you would. So that's kind of cool. So the way this works is that basically we install a custom URL handler for VM:, and the browser will send us this URL when you click on the links in a web browser. This gives you one-click power on without having to pick a directory or anything like that. I think it's in the next slide, but the great thing here is also that it allows for distributed publishing. I can start streaming a virtual machine, make some changes to it, like fix a bug, recompile, test it, and all the stuff that was necessary in order to download and to make those changes on disk. I can just upload to a web server and then point my developers or testers at that URL, and then they can get my changes as well. So you have this sort of distributed changing and reusing of VMs, which is pretty cool. And in fact, what you actually upload can be very small because it can just be your change set, the number of blocks that have changed in the virtual machine. So we'll look a little bit down underneath what's going on here. Oh, let's check on the booting. Let's see, this is doing something. We got a version of, this is a pretty simple Linux box that's going to boot Tomcat and a few other things. This BOS is the awesomest operating system that ever existed that was proprietary. So that's what we're booting here. That should come up in another couple of minutes. Let's see. Right. So, as I said, you're just passing a sort of URL, VM:URL to VMware or VM Player. And what that does is then goes and creates a special directory with the name of the virtual machine and the server from which you're downloading it in your default VM location. And we can look at that if we go. Hold on. So yeah, we've got directories, sort of temporary directories for the two VMs that we're currently streaming. If we do that, we can look inside and see that there's a bunch of files that are going on here, and the sort of most important ones are these cache file and this change file. And these are the VMDK files are sort of the file format that we use for disks. And the way that streaming actually works under the covers is that as blocks are requested by the virtual machine, they are downloaded remotely from the web server, put into this cache file, and then forwarded onto the virtual machine, just as if it was reading off of a physical hard drive. Anytime that the virtual machine writes some blocks, those blocks are put into this change file, change disk. And in the future, when the virtual machine tries to read blocks that have been changed, it'll return the changes that have already been written. That's kind of the nuts and bolts. Yeah, and here you can see, so what's really going on under the hood here is that we've got I'm going to use this laser pointer. Hold on. Can you see that? Anybody? No? All right. So what's really going on here is that you've got this this change file, which if blocks are not in the change file, will sort of yield to the download cache, which if blocks are not available in the download cache, will then go to the remote disk URL and fetch it. And then it'll sort of traverse back up the chain depending on how the VM uses those blocks. So the process here is pretty straightforward. We sort of iterate all the disks in the VM, create cache and change disks for them, power it on, and then sort of find the blocks that are what the VM is asking for. As I said, the blocks are fetched and stuck into the cache, and writes are stuck into the change file. And I can show you what happens when you power off, because a lot of times if you just click on a URL, you don't necessarily want to keep it around forever. Let's see what's going on here. Oh yeah, and you can see at the bottom here that it tells you the URL that it's streaming from, and you got a little throbber here that shows you when it's actually going to the network. So if I don't want to, I guess this guy's looks like BOS is still booting, as well as this one. So when you go to quit, we prompt. Again, this is beta, so there's some bugs. But what we do here is we prompt to ask if you want to save the changes that you've made. By default, we throw away the download cache so that the size of the VM on disk is really small. Basically, booting a VM will be between 10 and 15 megs that are written to the disk for a given boot. And because we don't want to throw away your changes, we ask you first. So I haven't done anything to this VM yet, so I can just discard it, and that'll sort of clean up all the disk files and remove it from my hard drive. And it's like I never clicked on the link. And let's see. Oh, and there's also the option of saving for offline use. So if you expect to be using this VM in the future, you can go here and click Save for Offline Use, which will let's see. Yeah, it should show you a little ticker here, telling you how much is left to be downloaded. And once that's done, the VM is essentially completely local and it will no longer hit the network at all. So it's just as if you had copied all the disk contents or the zip file or whatnot. Let's see. I'm not quite sure how fast the network is here, so that's affecting my boot time. Let's see. And so some of the future directions here are further speed optimizations, working on predictive downloading and based on the operating system type and the file system layout. Sort of work in progress. I'd also like to really explore peer-to-peer downloading of the sharing of blocks that have already been downloaded by other people who are also streaming this VM from the same URL. And I think that's got some really interesting prospects. So we'll see what happens there. There's also the idea of being able to click on an ISO that's on a web server and having that sort of create a VM around it and boot the ISO so that you can play with live CDs directly without having to boot them or download them or burn a CD or any of that stuff, which is pretty cool. Let's see if we've got a BOS to play with. It looks like it's still booting. Let's see. Sometimes we can do some tricks to speed it up. So that's basically my talk. I just wanted to introduce this feature that I think is really cool and could do some really interesting things. If we want, we can go look at this. We can go look at the directory that the data for this VM is being stuck in. And we can see that we've got about 64 megs of stuff that's both cache and changes. And that's pretty small considering that we haven't really done anything like download a whole bunch of data first. That's all blocks that have been requested by the VM. Right. So does anyone have any questions? Yep. There is no such process. That's kind of up to you. The idea here is that you can build lots of cool stuff around the basic process, but as long as we support as many web servers and as many VMs as we can, that we allow that stuff to happen. So, sure, no problem.
Any other questions?
Hey, that's really cool. I have two questions, actually.
Yep.
The first is there anything a sysadmin can do when they're partitioning to make it optimized for this use, like maybe making boot or the OS smaller?
Absolutely. So if you're an administrator today, there's a disk utility program that we have that allows you to compress disks, and that speeds up the process quite a bit. So what it does is take the VM disks on the server side, and if you compress them ahead of time, then people will download them in a compressed form, and that sort of speeds up the process quite a bit. There's BOS beginning to start up. Man, I love that operating system. Anyway, hopeful in the future that we'll make it easier for admins and users to create VMs that are optimized for streaming, and that could mean a whole lot of things. That could mean generating caches ahead of time. That could mean compressing the disks before you upload them. That could mean a whole number of things. Next question.
Does the streaming feature have any understanding of file systems? So is it able to predict what's going to be read next, or is it just like when a block is requested, it pulls it down?
Not yet. That is an astute question, though. We would like to do that, and I think it'll help quite a bit with boot times. Currently, it's pretty stupid. It's just it waits for the VM to ask for a block. When we get that request, we look inside the cache file. If it's on the cache, we download it. And there's some smarts there to try and group requests together and optimize a little bit. But we're still working on making it go really fast. But yeah, that's something we want to look at in the future. Okay. Next question.
If I've used the downloaded VM for some time, will this download continue in the background to complete the entire image?
Only if no. Currently, we only download by default. We only download stuff that the VM asks for. So it won't fill your file system up if you're not doing anything with it. But if you tell it to save offline, it'll start that process to. It'll sort of start a background thread that when the VM is not busy doing something that requires disk access, it'll download blocks and in the background, and eventually fill in the entire VM, so that you can then do whatever you would do normally with the VM. Anyone else?
Sure. There's kind of an overlapping problem set with what the OVF seems like it was created for.
Mm-hmm.
Are there any plans to, just like the OVF is a standard, not specific to VMware VMs, are there any plans to make this a standard or to integrate any part of OVF into this?
Yeah, I think OVF is kind of a standard for different virtual machine creators, like us or like Zen or like Microsoft to allow VMs to be sort of interoperable between these systems. And so OVF is kind of above and beyond this particular feature. I think that the integrations should just kind of fall out naturally. If you open an OVF file and the VM and the disk resources are stored on an HTTP disk on a remote URL, we should just be able to stream them down automatically. So yeah, I don't think I'm hopeful that as we integrate OVF more throughout our products, it'll just sort of it'll work, and we'll figure all that out. But I think currently the integration is not there. But again, we're in beta. Next question.
Testing.
Yeah.
So given that in 6.5 you've got all this great Unity features coming in, have you guys thought about for people wanting to just try out an app, or maybe their boss wants them to run some sort of app that's out on a virtual machine and they don't really know about this concept of virtual machines, sort of a one-click that brings up the app as needed in Unity mode, just that window. Is that sort of thing you guys are?
That's a pretty awesome idea. I haven't necessarily thought of doing that yet, but I mean, I think that would be really cool. I could definitely see that for instance, I use virtual machines all the time for work and for testing, but the virtual machine that I use most often is just an Outlook sort of shell. And so if I could just click on a link and get an Outlook, then that would be pretty cool. And so maybe we'll work on that in the future. Yeah. Good question, though. Anyone else? No? I don't know what I've got for time, but let's see. So yeah, we've now completed 5% of this download. I guess I've got some more time. If you want, I can. Okay, yeah, go ahead.
Did you see that there's a Haiku booth?
I'm sorry?
There's a booth for Haiku.
I saw the logo. Yeah, I haven't stopped by yet. Yeah, I'm kind of psyched to see what they're up to. So yeah, maybe BOS will live on. We'll see. I'll quit out of here. If you guys, I feel a little bit bad in that the schedule said that I was going to talk about something that I'm not going to talk about. So if you guys really want, I can try and demo latest in Pyro, latest in. Okay. Sure. Well, here we'll end that talk. That talk is done. It's done. All right. Thank you. So we just updated Pyro to work with the latest Firefox 3 beta, which is pretty cool. If you don't know, Pyro is essentially a window manager written inside Mozilla as a Mozilla extension, as a Firefox extension, so that it allows you to consider your whole desktop as a single HTML page. And when you move a window or when you resize a window, all these things are just regular DOM events. Windows are just represented as canvas objects with their content, which is live updated using the composite extension. This is just should start up Firefox with. Yeah, this is using the latest beta Firefox. I haven't inhibited the settings or the extensions update check yet. And so here's a really basic screen, and this is running in Zephyr. If in favor of brevity, I'm not going to try and start it up on the native X server, but that works just as easily. And so, all right, so here's GNOME terminal running inside Pyro. You can see that you've got translucency. And that just falls out of CSS, and because translucency is built into the into what it is to be a web page these days, and we can run gedit. Oops. Also, Chris Toshak wrote this extension which downloads Flickr photos in the background. That's written in HTML. This is a native application, and they're kind of running right next to each other with really no difference. And we can start up other apps. And again, everything inside this window here is being drawn by Firefox. Here's gedit. We can type. We can save. And so this all works. And that's all the demo I'm going to do of that. Does anyone have any questions or anything like that? Oh yeah, totally. it's interesting because we sort of we opted to hit all the hard stuff first. So, for instance, when you move a window, it's translucent, and when you resize it, it animates and does the resize all along and this kind of stuff. And so we're doing really difficult stuff as far as a web page is concerned. But the speed increase in Firefox 3 has gone up drastically. So I think it is, and as well as the memory footprint, which makes it basically useful as a window manager every day. Speed-wise, we're working on improving that. Also, keep in mind that was just shown inside Zephyr, which is an X server running inside an X server. I don't know. I don't know. Maybe. Sure. I don't know. I've never thought about it. The question was, what is the impact on remote systems running programs remotely and things like that? The answer is that there's not really an impact. It's something that's kind of interesting, but it's a little bit outside of the scope of what we've been doing with Pyro lately. So I'm going to say I don't know. Yeah. Well, luckily, as an extension, we can pretty much do whatever we want. So we can inhibit shortcuts, map them to what we would expect them to do. Make Alt F4 kill the app. Make Control refresh do something, or Control F5 do something that you would expect. And the interesting thing is that all of that is built on standard HTML and Firefox. Let's see if I can get a... any other questions? Anything? Oh. No? Okay. All right, now I'm gonna give up. I'm gonna cede the floor. Okay. Thanks. Bye.